How did our universe begin, and was there anything before the Big Bang? These baffling questions have bothered astronomers for decades, but now, with the launch of the $10 billion James Webb Space Telescope, we may finally find some answers. Launched on December 25, 2021 from Ghana's Space Center in South America using Ariane 5 rocket, the telescope has already reached its destination in space at Lagrange 2.1.5 million kilometers away from Earth. And while its instruments and cameras are still preparing for the work ahead, we will explain the greatest discoveries it might find since mankind began using the first telescopes. The earliest images of the cosmos we've seen so far, it's when the sky was opaque, until roughly 380,000 light-years after the Big Bang. Unfortunately, this is the furthest thing we can see. Our first pictures are from photons of the scattering surface of cosmic microwave background radiation. This precision image of the entire sky in this light, nearly 13.8 billion years ago, became visible as the temperature of the universe fell below 3000 Kelvin and hydrogen and helium atoms first became stable, permanently releasing CMB radiation, and the sky, previously charged plasma or high-temperature gas, became transparent. The cosmic microwave background radiation accounts even today for 95% of all photons in the universe. Discovered in 1964, the 1 CMB image of the entire sky has been photographed from specialized ground, balloon, rocket, airplane, and satellite-based equipment since. One of the Webb's primary goals is to explore the first galaxies more than 13.5 billion years ago, in an obscured period of our history that formed our universe as we know it today. Astronomers hope that by studying the earliest images of the cosmos, we can better understand what exactly caused the Big Bang in the first place and whether something existed before it or not. There is a hypothetical scenario called the Big Crunch. It will decide the ultimate fate of the universe, in which the expansion of the universe eventually reverses and everything recollapses, ultimately causing the cosmic scale factor to reach zero, an event potentially followed by a reformation of the universe, starting with another Big Bang. There is also another hypothetical scenario, the Big Rip. It's when the matter of the universe, from stars and galaxies to atoms and subatomic particles, and even space-time itself, is progressively torn apart by the expansion of the universe at a certain time in the future, until distances between particles will become infinite. During an observation with Webb, infrared light traveling from the target object or region of space is intercepted by the primary mirror, reflected onto the smaller secondary mirror, and then focused into the integrated science instrument module. Mirrors then direct the light into one or more of the 4 scientific instruments, which may focus, filter, block, or disperse the light before it's recorded. Webb's cameras will capture 2-dimensional images of regions of space that can be further studied here on Earth. Spectrographs spread light out into a spectrum so that the brightness of each individual wavelength can be measured, and later we can analyze the radiation from objects and deduce their chemical composition. Telescopes' coronagraphs are opaque discs used to block the bright light of stars in order to detect much fainter light of planets and debris disks orbiting the star. Filters are thin sheets of specialized materials designed to transmit a certain range of wavelength of light and block all others, similar to light filters on handheld cameras. Detectors absorb light and convert it into electrical charges so that the information carried in the light, like brightness, wavelength, and position, can be stored as digital data before being converted into radio signals and transmitted to Earth. By combining the data we have today with Webb's new discoveries, scientists will be able to predict the future that awaits us all. Astronomers don't know for sure whether nothing existed before the Big Bang, or it was just the beginning of another endless cycle of universe expansion and contraction. But one thing is certain: James Webb will forever change our understanding of the origin of the universe and will inevitably tell us much more about its future.